In this video, we're not doing anything new. We just got some more application problems with the system. So we're setting up a system, solving the system. We can use graphing. We can use substitution elimination. Graphing is the worst way of solving, so more than likely we're going to stick to substitution elimination. It says for each problem, define the variable, set up the system, and let's solve. So step number one, said at a fast food restaurant, 4 cheeseburgers and 5 small fries is 2,310 calories. 3 cheeseburgers and 2 small fries have a total of 1,330 calories. How many calories do each contain? So our two unknowns here would be the cheeseburgers, which we can let be C, the calories in a cheeseburger, and then the calorie in the fries, which we'll let be F. So that's your two unknown. We know that 4 cheeseburgers, which would be 4 C's, plus 5 small fries, which would be 5 F's, has a total of 2,310 calories. We know that 3 cheeseburgers from the next line and 2 small fries has a total of 1,330 calories. So to find out how many calories are in the fries and cheeseburgers, we're now just going to solve this system. Since it's lined up for substitution, let's go ahead and it doesn't matter which one you cancel. We'll go ahead and cancel our C's. So I'm going to multiply my first equation by 3. So it'd be 12C plus 15F's is equal to 6,930. I'm going to multiply my second equation by -4, which would give me -12C's, -8F's is equal to -5320. Now it's set up for my C's to cancel. Add these two together, I have no more C's. 15 minus 8 gives me 7 F's is equal to 6930 minus 5320 gives you 1610. When you divide by 7, it tells me that F is equal to 230. So that's the amount of calories in the fries. Going back and plugging it in, we'll plug it in here. So we have now a different color. 3C plus 2 F's, 2 times 230 would be 460, is equal to 1330. I'm not going to go through the steps, but subtracts 460 and divide by 3, and you find out that C is equal to 290. Number 2, 1 month a homeowner used 150 units of gas, 520 units of electricity for a total cost of $84.20. The next month, 210 of gas, 405 of electric, was $82.35. Find the cost for gas, which will let be G, and electric, which will be E. So 150 gases, 150 units of gas, plus 520 units of electricity was a total cost of $84.20. The next month, 210 units of gas, plus 405 units of electricity cost $82.35. So there's your system. Now we just got to figure out, do we want to do it with substitution elimination? Now with such large numbers, really neither one of them is going to be a great method. So let me show you what I do sometimes when I have such horrible numbers. There's other methods we'll talk about later, but for this one, let's use graphing. Now you might be saying to yourself, well, I thought that graphing you said was one of the worst methods. Well, it is if you're going to graph it by hand. However, we have a graphing calculator. We can use Desmos. Now, a warning, as you try to graph this on Desmos, you can't use G's and E's. So instead of G's and E's, I had to use X's and Y's. So what you've got here, you notice the graph. To where your red is your first graph there, your blue is your second graph. So I've graphed them both. And again, instead of G's, let's go back. Instead of G's and E's, my gas is the X value. My electric is going to be the Y value. So all I have to do is click on where they cross. They cross at the point 18, 11. So let me write that down. My solution is 0.18, 0.11, to where that is my X and Y, which in my problem was G and E. So gas cost 18 cents per unit, electric cost 11 points per unit. So anytime you're left with an ugly equation like this, graphing is an option if you use Desmos. Okay, number 3. Kim is renovating the first floor of her home. She bought 750 square feet of laminate and 525 square feet of carpet for that much. Usually from that first sentence, you can tell, first couple of sentences, you can tell what your unknowns are going to be. You don't know how much you pay for laminate. You don't know how much you pay for carpet. So that's probably going to be your unknowns. She went back to the store and bought an additional 100 square foot of laminate for 75 and 75 square feet of carpet for 374.75. What is the cost per square foot of each type of flooring? So let's come over here and put X. It's going to be we'll use X's and Y's just to where if we do need to graph it, it'll fit. X is going to be the cost of laminate, and we'll let Y be the cost of carpet. So the first time around, she bought 750 square feet of laminate, so 750 square feet of X. And she bought 525 square feet of Y. And she paid $2,717.25. Second time, she bought 100 square feet of X. And she bought 75 square feet of Y. And she paid $374.75. Now we'll try to solve this one by hand since we did the graph on the last one. Let me zoom in a little bit. So let's try to figure out X's or Y's, which is going to be the easiest to get the same. And I know that if I took my X values and I multiply by 2, that's going to give me 1,500. And I can change this to a 1,500 as well. So let's take the first equation. I'm multiplying everything by 2. And that gives me 1,500 X's plus 1,050 Y's is equal to 54, 34, 54, 34, 50. Then I'm going to take my second equation. In order to get a negative 1,500, I'm multiplying everything by negative 15. And there you see what I get. Now, once I do that, we are lined up perfectly so that my X's will cancel. So we got 0 X's left, and when I combine my Y's, I bring my equal sign down, and I combine my numbers, I now have this. And once I divide by negative 75, I get my Y value is 2.49. So what does that mean? That means that my cost of my carpet is $2.49 per square foot. Now I get the cost of my laminate. I now have to plug that back in. We can plug it in anywhere you want to. This is our smallest number, so let's plug it in here. So when I do plug it in, I now have 100x plus 186.75 is equal to 374.75. Subtract the 186.75, divide by 100, and that tells you that x is equal to $1.88. So the cost of my laminate was 1.88 per square foot. Number 4, Sean bought 1.8 pounds of gummy bears, 0.6 pounds of jelly beans, and paid $10.26. So we already see our unknowns. We don't know how much he paid for gummy bears. We don't know how much he paid for jelly beans. He went back and bought 1.2 for gummy bears, 1.5 of jelly beans, and paid $15.09. What is the price for each? So we'll let X equal gummy bears. And therefore Y would be our jelly beans. Now let's make a couple of equations out of this. 1.8 gummy bears, that'd be 1.8 X's, plus 0.6 Y's cost us a total of $10.26. The other equation says that 1.2 gummy bears plus 1.5 jelly beans cost us a total of $15.09. I do want to show you a trick before we go any further. If you're getting bogged down with the decimals, let me remind you of something from probably 4th or 5th grade. If you take a decimal number like 0.45 and you multiply it by 100, to multiply by 100, you can actually do so by just moving decimal points over. So it is a very legal thing to do to take equations and multiply anything times the equations as long as you multiply it by the whole thing. So if you don't want decimals, take the entire equation, first equation, multiply it by 100, which means move your decimal twice. Then you have your first equation is 180x plus 60y is equal to 1026. Your second equation, if you do the same thing, would be 120x plus 150y is equal to 1,509. So that cleans it up a good bit. If you're bogged down with the decimals, that's something that's tricky to have. Now let's look at the equations that we have left. We need to find some multiples. And I know the multiples of 150, and 300. And I know that 60 will also divide into 300, so I can turn both of those into 300s. So in order to do that, I'm going to take my first equation. Let's multiply everything by 5. And it turns into this. And now to get my negative 300 here, let's take my second equation and multiply everything by negative 2. And it will turn into this. And now we're ready to do work on it. So we see now that my y's will cancel using elimination. So let me draw me a line there. That gives me a total of 660x equals 5130 minus 3018, 2112. And then when you divide by 660, that tells you that x is equal to $3.20. So let's go back and see how we define these. So my x value is now $3.20. So now let's use that x value to figure out how much my jelly beans now cost. So if x is 320, we can plug it back in anywhere we want, any equation that we have up here. You can use these more complicated ones over here if you want to. We'll use this one. So we've got 1.2 times x, which would be 1.2 times 3.20, which is 3.84, plus 1.5y equals 15.09. Let's subtract the 3.84, divide by 1.5, and you'll find out that y then has a value of 7.5, and add your 0 on the end to make it a dollar amount. So jelly beans are $7.50. Gummy bears are $3.20. Okay, number 5 says Courtney has 88 stamps worth $15.56. Some are 25-cent stamps, some are 2-cent stamps. How many of each does she have? So our x and y, we'll let x be our 25-cent stamps. So therefore our y would equal our 2-cent stamps. So now let's set up some equation. I know there's a total of 88 stamps, so my first thing that I do is I know that if I add my x's and y's together, I'm going to get 88 stamps. They are worth $15.56. Obviously, each 25-cent stamp is worth 25 cents. So if I multiply 25 times x, plus I multiply 2 times y, that will tell me how much total money I have there. Now you've got to be careful. That's not in cent, or that's not in decimal form of money. This is in decimal form. So if I want to do 25x and 2y, instead of doing $15.56, I have to do 1,556 cents. Now, since we've used elimination so much, we'll try to use substitution on this one. Substitution is going to be fairly easy to use because I can get either x or y by itself really easy here. We'll just move our x's over, and I'll put that y is equal to 88 minus x, or negative x plus 88, either way. Down here where I have a y, I'll substitute that in. So I have 25x plus 2y equals 1556. In the place of that y, again, I'll put the 88 minus x, and now we're ready to solve. 25x plus 2 times 88 is 176. 2 times negative x is negative 2x is equal to 1556. Combine your like terms, you have a total of 23 x's, and if you would like to, you can go ahead and move that 176 over by subtracting. 1556 minus 176 is 1,380. Divide both sides by 23 and you get 60. So my x value is 60. So let's go back up here. My x was my 25-cent stamp. So there are 60 25-cent stamps. Since x plus y is 88, that's going to be the best place to plug that in. And you're going to find out when you do 88 minus 60 that there are 28 2-cent stamps. Okay, number 6. Tom put 18 gallons of mid-grade gas in his truck, filled up his empty 5-gallon gas can with regular gas for his lawnmower, spent $59.91. The following week, 14 gallons of mid-grade, and topped off his 5-gallon can with just 1 gallon of regular gas and paid $39.75. Prices remain the same, so how much mid-grade, how much regular? So we'll do X. Will that be a mid-grade price? Mid-grade price. Our Y value will be our regular price. We know that 18 gallons of mid-grade, that'd be 18 X's, plus he filled up his empty 5-gallon can, so he did 5 Y's, 5 gallons of Y, and it cost him a total of $59.91. The next week he did 14 gallons of the X, and he only bought, he topped his 5-gallon can off with just 1 gallon of regular plus 1 Y is equal to, and he paid how much? $39.75. Now, I'm a big fan of substitution when substitution works. And substitution, since I have plain Y right here, it'd be very easy to use substitution. So what I'm going to do, I'm going to take my second equation, I'm going to solve for Y, and I get Y is equal to 39.75 minus 14x. We can now take my other equation, and in the place of the Y in that other equation, I can replace it with that Y value. So I have that Y value was 39.75 minus 14x. Distributive property gives me 18x plus 198.75 minus 70x is equal to $59.91. And again, it's just a basic equation now. Combine your x's. 80 minus 72 gives me negative 52x's. If you'd like to go ahead and move this over, you're going to subtract 198.75, and that would be negative 138.84. When you divide that by negative 52, you find out that x is equal to $2.67. So that's how much you paid for the mid-grade. Now let's see how much you paid for the regular. Take either one and plug it in. Again, the best place if you're using substitution to plug it in is always where you solved for your y. So to figure out what y is equal to, you're going to do 39.75 minus 14 times 267, and you're going to get $2.37. So that's how much you paid for mid-grade and how much you paid for regular. The next one, number 7. Total of $12,000 is invested in 2 types of bonds. And you can already see here's where we're headed, where there are 2 variables. One pays 8% simple interest while the other one pays 10.5%. Last year, the annual interest earned on the 2 investments was $1,145. How much was invested at each rate? So X, it was invested at, let me do a better at symbol there. Invested at 8%. And we're going to let Y be the amount invested at 10.5%. Now, since it's a simple interest, that means that if you invest something at 8%, that after 1 year, then however much you invested, 8% of that you're going to earn extra. the way that you find 8% of something is the word of means to multiply. You're simply going to multiply by 8%, 0.08. Same way with 10.5%, you're going to multiply by 0.105 to find out how much interest you're going to earn. So we invested a total of $12,000. So that means the amount invested in X plus the amount Y that we invested at 10.5 is equal to a total of $12,000. And we can already see, according to that, it's going to be pretty easy to use substitution. Okay, we invested 8% of this amount of money at 8% interest. That means that we're going to earn 8% of that amount extra. Plus, we're going to earn 10.5% extra for this, so 0.105. That's 10.5% of Y is how much extra money we're earning. The total amount earned is $1,145. Again, we can use substitution or elimination. If you want to get rid of your decimals here, here, and here, you could actually multiply everything by 1,000. I'm going to try to just leave it, and we'll work with it as is. I'm going to take my values up here, and I'll just solve it for Y. We get Y equals, move the X over, and you can do 12,000 minus X, or you can do negative X plus 12,000. In the place of my Y in my other equation, I'm going to replace it with that. So I now have the equation 0.08x plus 0.105 times Y is equal to 1145. And my Y value is 12,000 minus X. Let's solve this equation. It gives me 0.08x. Let's multiply 0.105 times 12,000. And you get 1,260 distributive property. That'd be minus 0.105x is equal to 1145. Combine your like terms. 0.08x minus 0.105x is negative 0.025x plus 1260 is equal to 1145. And you could have went ahead and moved that over if you'd like. Next step is going to be negative 0.025x. Move that over by subtracting. So 1145 minus 1260 gives you negative 115. When you divide that by the negative 0.025, you get $4,600. And since I ran out of room, I'm going to write it up here. So your X value is $4,600. Now the Y value is going to be very easy to find because your Y value is simply 12,000 minus that X value, and that's going to give you $7,400. So that's your amount invested in each. Last problem. A collection of dimes and quarters are worth $9.55. Again, if you don't want to work with the decimal point, we can use 10s and 25s as long as you use 955. Quarters and dimes, if the quarters were dimes and the dimes were quarters, the value would be $7.60. Find the number of each coin. So we'll let X be the number of dimes and Y be the number of quarters. And this one's a little tricky. The collection's worth $9.55. I know that each dime is worth 10 cents. So we're going to do 10x so I don't have to worry with decimals. 10x's. I know that each quarter is worth 25 cents, so we're going to do 25 Y's. And if we're going to do it in cents, then that's going to equal a total of 955 cents. Now the next part is the tricky part. If the dimes were quarters and the quarters were dimes, okay, so that means that each dime would be worth 25 and each quarter would be worth 10. So that would mean that each dime was worth 25 cents plus each quarter now would be worth 10 cents. So if the dimes were quarters and the quarters were dimes, then your collection would be worth $7.60. So that'd be 760. And again, we can use substitution, elimination. Either one of them is not going to be too bad here. You can, again, I'll show you another trick. You can reduce these equations because I noticed that all of these are multiples of 5. So that might help. Let's take both equations. Let's actually divide everything by 5 and see if that helps us out any. And you can see there that it does. It actually makes our numbers so much smaller and looks a whole lot better. So now you can get either your x's or your y's to cancel. I'm going to take and multiply my first equation. Well, we actually shot ourselves in the foot by that, because I'm going to have to multiply that back by 5 to give me a 10x and a 25y equals 955, which was what I started with. But now I can take my second one and multiply by -2, and I've got my x's canceling. -2x, a -4y, and a -304. So it worked out good for us on one of the equations, but not as well on the other. My x's are now gone. 25 minus 4 gives you 21 y's left. 955 minus 304 gives me 651. When you divide by 21, you get your y value is 31. And again, had you got something crazy, because domain-wise, we're talking about the number of quarters, the numbers of dimes. So if you'd have got something crazy like 31.8 or something like that, you know that you'd have to be wrong, because you have to have a whole number there. So your y value is 31. And we can plug that into either one or any of our equations that have x's and y's. Now, these cleaned up versions would be nice places to plug them in. So let's do 2x plus 5y would be 155 is equal to 191. Solve that equation. Let's subtract 155. Gives me 2x is equal to 36. So my x value must be 18, which means there are 18 dimes and there would be 31 quarters.